here we have a question that gives us a graph with a picture, and you've got the function e to the 2x minus 5 e to the x plus 4. They've drawn it out for you, and you need to do a few things, which is work out the horizontal asymptote through C. You need to find the coordinates of A over here, which is an x-intercept, and B, the stationary point. So a bit of calculus involved there. This time do it in exact form. Find the equation of the normal through this point, and then a question on Newton's method. So let's do that. So starting with our function, y equals f of x equals e to the 2x minus 5 e to the x plus 4. And with the approximate diagram given before, it's expected that you've got a horizontal asymptote at some level, which we've called C. And you pass through the origin, and you have a minimum sort of situation like that in rough terms. So we want to find the horizontal asymptote through C. Now, to find the horizontal asymptote, you'll recognize that this is going towards the left, which is as x goes to negative infinity. So to answer part 1, we really need to determine the limit as x approaches negative infinity of fx, which is the limit as x approaches negative infinity of e to 2x minus 5 e to the x plus 4. But notice that for the e to the negative, notice e to the negative infinity is 0. So as x goes to negative infinity, then the exponential, the power of both of these goes to 0. And we know that goes to negative infinity. And so these expressions go to 0. So this is basically going to get towards 0 minus 0 plus 4. So the limit is 4. So in other words, this is the line y equals 4. Part 2 asks us to basically do a bit of calculus and find the y-intercept, the x-intercept, sorry. So we need to let y equal 0. So we'll get e to the 2x minus 5 e to the x plus 4 equals 0. You should recognize that this is basically e to the x So it's basically a reducible quadratic. E to the x all squared is e to the 2x. Minus 5 e to the x is just minus 5 e to the x plus 4. So we can basically solve for this. You can factorize. So e to the x, think of it like a u if you like. U minus 4 and u minus 1 will give you u squared minus 5u plus 4, which is what we need. That means e to the x equals 4 or e to the x equals 1, because they need to independently equal 0, which of course means x equals log 1, which is 0. So that's the origin one, or x equals log 4. So this is at log 4, 0. Now, we are then asked to find the stationary point. I'll do that working here on the left. Actually, I'll just give myself a bit more space here. None of that working is really do that. So now we want to find the stationary point. So the information is already labeled on the graph. We want to find the stationary point. So as usual, to find the stationary point, we take the first derivative. The functions are there on the left. So we take 2e to the 2x, that's the derivative of the first term, minus 5 times the derivative of e to the x is e to the x, and then plus 4 is just 0. We want this to equal 0, noting that e to the 2x is e to the x times e to the x, we can factor out e to the x. Now, because e to the x can't equal 0, I mean, it's an exponential, the only way you get the first derivative equals 0 means 2e to the x minus 5 equals 0, which means 2e to the x equals 5, e to the x equals 5 over 2, or x equals log 5 over 2. Now, they want the coordinates of b, so you can't just leave it in terms of the x coordinate. So we need to find the y as well. Y equals e to the 2 times log 5 over 2 minus 5 e to the log, which is 5 over 2 plus 4. So we'll treat it as e to the log of 5 over 2 all squared minus 25 over 2 plus 4. So it's going to be 25 over 4 minus 25 over 2 plus 4. Which is negative 9 over 4. So we expect that this is log 5 over 2, negative 9 over 4. And we have no reason currently to expect any of that is wrong because it does match what the graph is showing. The next part asks you to find the equation of the normal through 0, 0. So essentially, we've got a tangent line that looks kind of like this. And you want to find a normal, which will be perpendicular to that. So it'll look something like that. So in other words, we know it passes through the origin. We know it passes through the origin. And just from the diagram, we know it's kind of sloped sort of to the right and up. So we know it's y equals some sort of kx without a c, because it goes to the origin. And if it's a straight line, the normal is a straight line after all, that goes to the origin, then as long as we find the gradient and put it into k, then that will be the equation of the normal, because after all, it's going through the origin, it's a straight line that we know expect to have some gradient, which we expect to be positive from the diagram. So just really need to find that gradient. That's all we need to do. So keeping in mind that this is the first derivative, okay, and we don't really need that there anymore. But keep in mind that if that's the first derivative, then that means that at 0, 0, f dash 0, which is the gradient of the tangent, is just going to be 2 times e to the 0 minus 5 e to the 0. So it's 2 minus 5, which is negative 3. So in other words, the gradient of the tangent is negative 3. In other words, the green line, as expected. But the gradient of the normal must equal negative 1 divided by negative 3, because gradient of the normal times the gradient of the tangent equals negative 1. So that means it's a third. If you know that the gradient of the normal is a third and you know it passes through 0, 0, then you automatically know that the equation is y equals 1/3 x. Now, you could have gone ahead and did it with a point gradient formula with your y minus y1 equals mx minus x1, something in 0, 0. It'll take you slightly more work, an extra line, maybe 2. You should still get the same answer, but you recognize that it's basically this upward sloping curve and that passes through the origin, so that's just it. So the last part says the normal intersects the curve at another point n. Okay, so let's extend this. So we're expecting it to basically intersect here, and this will be the point n. The x coordinate of n is apparently close to 1.5. Well, it's certainly to the right of a, and log of 4 is 1.38. So 1.5 looks reasonable, roughly. They ask us to use one application of Newton's method to find the value of n and round the answer correct to 3 decimal places. Now, one thing to note is that the decimal point, the Newton's method is not actually needed in the formula, in the exam anymore. However, this is going to be a good opportunity to show you why memories are, calculated are so useful. So